Okay, let's get started. Thank you for being here in this horrible slot at the tail end of the conference. I didn't think I didn't think we'd get this many people. I'm Matt Klein. I'm up here with a bunch of the Envoy maintainers. So the format, and I'll let them introduce themselves just a bit later. We're just going to do a quick, like 15, 20-minute presentation for those of you that don't know what Envoy is. And then we'll do a Q&A session where folks can ask whatever questions you want, and we'll let all of the maintainers answer. And we probably won't use the whole time, but we're happy to stay here for the whole, I think, like hour and a half block for Q&A. Okay, let's go. So just a quick overview of networking in the cloud native space right now in terms of what most end users are actually facing. We are living in a world these days where most companies are not a one language shop anymore. The days of all Java are pretty much over. Through acquisition or just general trends, we now see most companies that are using many different languages. And within those languages, they're using lots of different programming frameworks. So that leaves us in a situation in which folks are struggling with figuring out how to operate their systems and do networking across all of these different code bases. We have a lot of different protocols. Obviously, we have HTTP, we have gRPC, we have databases, we have caches. Lots of different types of infrastructure that folks are facing. We have VMs, we have containers, we have functions. We have people that are running in on-prem cloud. We have people that are running in base on-prem, bare metal. We have people that are running in public cloud. Lots of different load balancers that people are using. We have cloud load balancers, software load balancers, hardware load balancers. And in terms of observability, how people operate these systems and get stats out of them, they're all very different. So if you're using a cloud load balancer, it produces certain types of stats and logs. If you're using an F5, it produces different types of stats. So it can be quite confusing. And from a distributed system perspective, as the industry moves more towards microservice architectures, there's a lot of best practices that people need to have, things like circuit breaking and rate limiting and retries, et cetera, et cetera, et cetera. And the implementation of all of these things end up being different across all of these different libraries and frameworks and load balancers. Obviously, lots of different concerns around authentication and authorization that folks have to deal with. And where this leads right now is that, for people that have lots of different languages that they're using, we wind up typically with per language libraries, for people who are trying to make RPC calls, for people who are trying to do timeouts, retries, circuit breaking, stats logging, and tracing. And that leads us here, which is typically a place of pain. So what is Envoy? The goal of Envoy is that we'd like to make the network transparent to application developers. I often say at all of my talks that infrastructure is mostly overhead. So we would like our application developers to be focusing on writing business logic, and any time that they're spending fighting with networking or databases or orchestration or any of those types of things is time that's not well spent for the company where they work. So the goal of Envoy is a transparent substrate where we can mediate a bunch of the concerns that application developers have to deal with, particularly in the networking space. So those are concerns, again, around service discovery, load balancing, observability, et cetera, et cetera, et cetera. So, I've given a variant of these slides for many years at this point, and a couple of years ago, I had to, do this "what is service mesh" slide. Now, service mesh is, the subject of epic vendor battles. So I'm sure all of you are pretty familiar with service mesh at this point. But if you're not, The idea behind the service mesh is that I have a bunch of different applications that are written in different languages. I have to do all of these, again, similar concerns around service discovery, load balancing, observability. So what I do is I take my application, I co-locate it with a proxy, and then I essentially send and receive all of my networking RPC calls through that co-located proxy. And thus, the application only knows about its local proxy, and then that local proxy is going to send the traffic out and get the response and do things like tracing and retries and load balancing. So from a feature perspective, Envoy is a network proxy. So for those of you that are not, sorry, it's a software network proxy. So you've probably heard of Nginx, you've probably heard of HA proxy. Envoy would be most similar to those pieces of software. And so it is an out-of-process architecture. It is not a library. It is a modern C++ 14 code base. I know that Lizan would like to make it a C++ 17 code base, but that has not happened yet. And fundamentally, Envoy is a L3, L4 filter architecture. So what that means is that it operates at a TCP or a UDP level in terms of bytes in, bytes out, and then we can write filters that can transform those bytes and do various things. So that could be inspecting protocols. So for example, we have a MongoDB filter that parses the MongoDB data stream and produces stats. We have an HTTP filter, which parses HTTP1 and HTTP2, and then obviously transforms that into higher layer constructs. We have people working on Kafka. We have Redis. We have authentication. We have all types of things. Because HTTP is so important for modern architectures, we have a parallel layer 7 filter stack for HTTP. So unlike at L4, where we're dealing with bytes in and bytes out, at the L7 layer for HTTP, we're dealing with headers in, body chunks, and then we sometimes have trailers. And we have a different set of filters at this point in the open source code base. There's probably 15 or 20 of them that do things like buffering and rate limiting and authentication and authorization and et cetera. It's not as important now as it was, but when Envoy was first produced, it was written to be an HTTP2 proxy first. And the reason that's important is that HTTP2 is a multiplexing protocol. So that means that one connection can carry parallel streams. And at an architectural level, Envoy was built so that everything looks like HTTP2. So HTTP1 is translated to look like a connection with one request on it, but for most of the code, it's not aware that it's HTTP1 or HTTP2, and that has important implications from an architectural perspective. That also allowed Envoy to be one of the first proxies that could do gRPC. It has quite a few different features in terms of service discovery as well as health checking. So service discovery is how do I find my backend hosts. We support DNS. We support our own API called EDS, the Endpoint Discovery Service, which I'll talk about a bit. We support static configuration, et cetera. Active passive health checking. So active health checking is actively sending out a ping and getting a response. Passive health checking is monitoring traffic for say consecutive 500s or success rate outlier. I will talk about this more, but Envoy has become very popular for its configuration APIs, which we call XDS, that is Star Discovery Service. And Envoy has quite a few different load balancing features, from being able to do failover from a priority perspective, from calculating like healthy hosts and ejecting them, and the documentation section on load balancing is very long and very confusing to the uninitiated. We like to say that we have best-in-class observability, so that would be stats, logging, and tracing. We put a lot of effort into making sure that Envoy is easy to operate. And Envoy has many features that allow it to be used as an edge proxy. So things like TLS termination. We are spending an increasing amount of time on security. And the reality is that the code that's used in an edge proxy versus a service mesh proxy or a middle proxy is 99% the same. So what I typically tell people is that having one piece of code that you learn and you operate, and you use that for all of your load balancing needs, it's easier from an operations perspective, because then you have one set of stats to understand, one set of logging, one set of configuration. I won't spend too much time on this diagram, but this is a high-level block diagram of Envoy. And what you'll see here is that Envoy, as I said before, is composed of a bunch of layer 4 filters. And those filters are composed in blocks, which we call filter chains. So when a connection is received, it's assigned to a worker thread. We set up a set of filter chains that operate in sequence at layer 4. In many deployments that are using HTTP, one of those filters is an HTTP filter. And then we have a parallel set of layer 7 filters. And then on the back-end side, we have a thing which we call the cluster manager, which manages all of our backends, connection pools, et cetera. One of the interesting architectural decisions that was made with Envoy was that we decoupled the front end of the system, so the listeners, from the back end of the system or the upstream proxying. And that allows Envoy to operate as a transparent proxy. So for example, it can transparently proxy HTTP1 to HTTP2 or HTTP2 to HTTP1, or there's many other scenarios like that. And we have a bunch of abstractions in place that allow most of these components at this point to be fully pluggable. So people can plug in their own custom clusters or load balancers or filters or things like that. So I talked about it before, we like to think of Envoy as a universal data plane. And at this point, we have lots of APIs. We've gone when we open source in 2016 to having one API to I think now we probably have 10. I think Harvey gave a talk at EnvoyCon where I think our API alone is something like 15,000 lines of proto or something like that. We have a lot of APIs. And, this API-driven configuration, which allows Envoy to be configured from a central management server versus having to send out configuration files to each proxy, has been one of the defining features that has made Envoy so popular so fast. And we have people that use Envoy in a variety of different deployment scenarios, and they use their management servers implement different portions of the API, and this allows Envoy to be configured in an eventually consistent manner. But essentially, it allows Envoy to be deployed and then configured centrally such that you can build a distributed mesh of Envoys. We allow these APIs to be called both through a gRPC streaming mechanism. So the canonical form is actually Proto 3. And then we also allow a JSON YAML REST version of those APIs, though they're less fully featured because there's no streaming in JSON YAML calling. But as I said, this is really about allowing in highly volatile architectures, or where we're doing a bunch of auto scaling and things are coming up and coming down. We can now avoid having to do this dance of having templating and having to send out configuration files to all of the hosts. We can have central management. And the goal, and I think where many companies are getting to with Envoy, is having a bootstrap configuration that is shared by all Envoys, and then all of the configuration comes from that central management server. So, as I said before, from an extensibility perspective, we now have probably 10 or 15 different extension points. So we started with only filters, but now we have the ability to plug in access loggers and tracers and health checkers, and the list goes on and on and on. And this has been, I think, one of the other defining reasons that Envoy has become so popular. We've seen people take Envoy now, and it's just used all over the place. We have people that have built companies on top of Envoy with custom extensions, and they use it in their other products. So we've been able to build a base product that now is used in all types of different deployments. So just a very brief history of Envoy. I started Envoy at Lyft in 2015. We worked on it at Lyft for about a year and deployed it fully. So it was deployed as our edge proxy and our quote service mesh proxy. And we open sourced Envoy at the end of 2016. And at the time, I thought it'd be great if someone would use this thing, and just wasn't sure what would have happened. And it's been a pretty amazing ride since then. So that was a picture of me in 2017, looking very, very sad. 2017 was a period of just a rapid growth for the project. Lots of new investment, lots of companies started using Envoy, lots of project growth. We joined the CNCF at the end of 2017. We became a graduated CNCF project at the end of 2018. And now at the end of 2019, pretty incredible to me, but Envoy is used pretty much everywhere. This is just a small list of the adopters, but it ranges from end user companies like Lyft to all of the major cloud providers to lots of startups that are now using Envoy as part of their product, and obviously lots of service mesh products that are based on Envoy. From the project perspective in terms of why it has, again, become popular is that I think that we've been able to maintain a really high quality bar. We have pretty incredible velocity. It's a very extensible platform. We have a pretty flexible and rich API that people can use to actually use it. And then we get into the more interesting things, which is that Envoy is fairly unique at this conference in the sense that it was not created by a VC-backed company. It was not created by a cloud provider. It's actually an end-user-driven project. And we've been able to build a stable of maintainers and contributors that span really all of the cloud providers, lots of end user companies. So it continues to be a very end user driven project, which is great. And that means that there's no open core version. There's no enterprise version. It's not open core. So we don't block any features. We allow pretty much any reasonable change to come in. And I'm most proud of the larger community. I think it's really incredible how many people come to EnvoyCon and are pretty excited about the software. So that's great. So I am going to end there. Just a quick little overview of the project. I'm going to hand it over and let the maintainers that are here introduce themselves and just say briefly where they work and what they work on. And then I will run the microphone around and we can answer as many questions as people have. So thank you.
Hi, I'm Harvey Tuch. I work at Google. I work on Envoy API and security topics. And yeah, I'm asking any questions about APIs or UDPA.
Hi, my name is Lizan Zhou. I work at Tetrate, and I work on the Envoy build stuff and get Envoy stuff, as well as the Istio data plan lead. Work on WebAssembly stuff as well.
Yeah, I'm Snow. I work for Square. Been working on the Square internal service mesh for like the last 2 years or so. And yeah, mostly been doing like load balancing, kind of upstream work up in Envoy.
Hi, and I'm Jose, and I work at Lyft. I've worked on this space with Matt for about 3.5 years. First with Envoy in server networking, but more recently we started a new project called Envoy Mobile to bring Envoy to our mobile clients.
Cool. I will run the mic around. So who would like to ask the first question? Actually, if you don't mind, I'm thinking if maybe people could just come forward with the mics, or maybe people could just come up here because we need the questions recorded here.
Hi, I'm Vladimir, Spotify. So in Spotify, we have in the client a very large client core. It's like C++ app. And I guess the question is about Envoy Mobile. And in this core, we have a problem with like Android is fine, but iOS is very like restricted. And it's kind of hard to use BSD sockets. And like, do you envision some problem in the space like Apple, like failing Envoy Mobile in this scenario?
I mean, it's hard to, I don't work at Apple, so it's hard to say what they will do and they won't do. What I can say is that, for example, one of the extension points at Envoy is its transport sockets. And so there's ways that if they restrict, some of the code base because of one reason or another, we have ways to, potentially work with the APIs that they actually expose and replace things that are problematic.
Yeah, I was going to say too, I'm not really worried just because there are two substantial prior art implementations in this space. So Facebook already does this, and so does Google. So I can't really imagine what we would be doing, which they would block.
Yeah, I have a question about the last point here, community. And I'm sure that all of you overlap with some other tech communities as well, like KubeCon is kind of a bunch of overlapping Venn diagram of tech communities. Obviously, Envoy's got a real strong one, but as you look out at other communities, are there aspects that you see, are there like habits or rituals or things that you want to borrow and bring in? Are there other communities that you look up to and are modeling yourselves after?
Yeah, so I think the Kubernetes community actually, and not just because of the current audience, but we've actually been drawing a lot from them in terms of establishing some of our best practices around security handling and CVEs, and I think that they've had to confront many of these issues well before we have, and we also see them as probably a more complex project, but one which has many parallels to Envoy, and one which we could certainly draw from. Also, as a result of sort of their involvement in CNCF, I think in general, CNCF could do a really great job at trying to unify and harmonize some of these common process and governance and sort of CI kind of things across projects. And so, yeah, probably a combination of Kubernetes and CNCF is, I think, where we definitely look a lot at these days.
I think another good point is as Envoy grows and there's a lot more areas of expertise, another thing that we are adopting is working groups. So like the UDPA working group that will allow people to specialize in the areas of interest that they have.
Yeah, for me, I think probably Kubernetes. I think there's portions of the Linux kernel that are worth looking at, not others. But we are increasingly having many of the scalability issues that some of these larger projects have. So there are things to be learned, for example, from the Linux kernel in terms of how they treat drivers versus how they treat the core kernel, and that's very similar to Envoy for how we treat extensions versus core Envoy. So I think, and we're starting to figure out how to do stable releases. So looking at how the Linux kernel does stable releases is also very useful. The flip side of that is that having some of these larger examples, it also helps us learn from what we might not want to do. So, for example, if you look at how Kubernetes and some of the projects do CI and how they integrate with GitHub, I think there are some painful parts of that. So we're also trying to learn from some of those problems and hopefully make sure that we don't make the same mistakes. But it's difficult, yeah.
Hi, hello. I would like to ask a little bit about the features of Envoy, and one particular thing, and that's source IP and not for HTTP. Any idea how that could work, for example, for a protocol like POP3 email, if in case we use TCP as the type of forwarding? could that work somehow with to get the source IP of a client? If clients like wants to send email, we try to use that as a load balancer to our backends. Any idea, any chance to get the source IP from that with that?
I can take it. Sorry, so are you asking, is there a way to get the source IP? Yes, yes, yeah. You can just get the source IP. Yeah. Yes, so for the TCP filters, we give you raw access to the actual connection. So you can grab the source IP from the connection, and then you can do what you want with that. Sorry, are you asking, can you proxy with the same source IP that the client used? Okay, okay. Yes. There are people that are doing that. This is probably a bit arcane for this audience, but there is in the docs, or if you send us email, there is a section on IP transparency, which talks about this topic. So yes, it is possible with a bunch of IP tables trickery and some other stuff.
How about some common pitfalls or that you see folks running into in terms of integrating into Kubernetes, just as someone who then is moving towards using envoys within Kubernetes, common stuff that you see?
Sorry, are you asking with Kubernetes specifically or just with Envoy in general? Sure. Lita, would you like to come forward? Come on, Lita. Come forward. Yeah.
Oh my God. Okay, so the common pitfalls I have seen have been around the amount of changes that Kubernetes enables. So like in virtual machines, things are relatively stable, because people tend to mutate their infrastructure, but Kubernetes is an immutable infrastructure, so things are changing a lot, and I think we've seen a lot of issues with the control plane, all this data coming in and sending it out to all the sidecar envoys. Some pitfalls are around also. Envoy has this feature called panic routing that enables that notifies you in a loud way that mesh isn't converging, and it's just due to the fact that things are changing so fast, and your control plane is trying to keep up. And so I think Istio is having this problem as well, and it's something the community needs to figure out. Incremental, what was it? Right now, the XCS API send the state of the world, and the community is working on Delta. I think it's Delta subscription. What was it called? Incremental XCS. And so there are things that are happening to make it work better. But yeah, those are the common pitfalls I see because there's just so many changes.
I think the problem that we're having right now is that basically every large company that is adopting Envoy is writing their own control plane. Like there are hundreds of control planes out there. And it just isn't true that any of the open source service mesh control planes right now, they're not really heavily used, right? I mean, it's like there are people starting to adopt Istio, and then there's Console Connect. And I mean, there are other products, but they're not used at any large enterprise. No matter what any of the vendors tell you, it's not true. So with that said, we're trying to figure out, like, we don't want hundreds of people to individually write their own control plane. So we're trying to figure out from a project perspective, like what can we do to make that simpler? But unfortunately it's not an easy problem because everyone's infrastructure is slightly different. So from what Lito was saying, I think there are patterns that control planes have to do, particularly around batching. So, if the infrastructure is going like this all the time, you can't send every update out. It's not going to work. So, I mean, they have to implement batching and caching and various other things. So then the question becomes, can we potentially put some of this logic into Go control plane, which is our control plane library? But, it's relatively early days. And what I would say, and again, this is different from what the vendors will tell you, is that service meshes are very, very complicated. Like, do not do one unless you are already having such bad problems that the alternative is worse, right? And I think that's not what the vendors would tell you, but that's what I would tell you. So you have to be ready to invest a significant amount into making this making it work, because the alternative is even worse.
Also, another plug for Lita. She gave a very good talk at EnvoyCon about some of the pitfalls that we encounter with service discovery with Kubernetes. So whenever those videos are up, just look for her name.
I mean, is there anything from the SDL perspective that you want to mention? No. Well, like there's like SDL is like recently getting more adoption. It's used like one of like large deployment like Sriram had a talk with Freddie Mac, and you see the Walmart labs in the keynote as well. So it's getting more and more stable. Then we expect that will become like more easy to adopt in the like next couple months. Yeah.
Hey guys, I think you were working on Quick. Is that done already, or is it soon to be released? Support for Quick. Thanks.
I've been working on UDP proxying, so just base UDP proxying. That's be part of the final Quick solution. That will hopefully merge in basic form in the next 2 weeks or so. Dan from Google, she's working on the actual L7 Quick support. I think we're still planning on having an MVP, something that can be tested by the end of the year. We're committed at Lyft to getting it out to production probably in H1 of next year. So, and there are other people too that are interested in this. So, like Quick is very complicated, and there's a lot of moving parts in terms of how it actually has to be deployed. It's much more complicated than just doing something with TCP or HTTP2. So it's going to take some time to figure out what that looks like. But we're pretty close to having like a basic version working for initial testing.
I have a quick question. I've been hearing a lot about the service mesh interface, and I wanted to know what your thoughts are around that. Sorry, Harvey.
So yeah, I won't claim any deep knowledge of the service mesh interface specification, but having chatted with a few folks about this, I mean, what we're talking about is something at a different level of abstraction, for example, to Envoy's APIs. The idea is really essentially at the level of abstraction of something like Istio's APIs. Can we create a common set of a standard which could sort of generate config which would be suitable for all these different service meshes and simplify their management and so on. And yeah, standards are great. Yeah.
I mean, to me, it's like not directly related to Envoy itself. It's more about having all the different service mesh implementations which might use Envoy under the hood, make it easier for users of those to kind of like swap out different implementations. The API service of SMI versus Envoy is like, it's so different. Envoy has like hundreds of more features than SMI, so it's like it's not really, they're operating at very different levels.
The only thing that I would add, and this is my personal opinion, obviously, is that my concern with SMI is that it's going to wind up being something like Kubernetes Ingress, where like the simple version is not going to be useful to anyone actually. So there's going to be lots of vendor-specific extensions, and then what's the point of having that thing in the first place? Like I'm not opposed to it. I'm just dubious that it's going to end up having real value, because for the simple things that this comes back to, should you have a service mesh? And I think for the simple API, if the simple API works for you, you probably shouldn't have a service mesh. I mean, it's like too much complexity. So then if it doesn't work for you, well, now you need all these other features, and then are you gonna add all those features, and then you just wind up with the Envoy API again? I mean, it doesn't make a lot of sense to me personally.
Thank you. So I'm interested in a particular use case, which I don't know if it's supported, or if it's not, maybe, if it could be supported somehow. So there's retries, right? And there's timeouts. Let's say I want to connect to a service which is down right now because I want it to be down. Then I'm going to wake up the service. And I don't want to wait until the next retry comes to actually start proxying the traffic. By the way, I'm thinking TCP. So is there any way I can tell Envoy, hey, service is awake now, try again because it might work this time?
I feel like you could probably write a plugin to do that. I think maybe.
Well, so the way you kind of tell, yeah, you can totally like hook in. There's like plugin extensibility, which lets you impact which hosts are selected, and also kind of rearranging like the like which regions you're sending retries to. So there's a possibility of using those to impact that choice, and you can have those kind of like be able to like look up this data. Now, the way that I would imagine this kind of happening is that you're going through the XDS API, where it waking up is changing the configuration and kind of adding that host into the pool of considered host. And in that case, your retry would just be able to pick it up normally like any other thing. Now, so it kind of depends on your exact use case, and like, yeah, so there's a lot of different ways of doing it. Yeah, so it kind of depends.
So yeah, I think the retry plugin framework that exists today is a suitable basis for this, but it probably needs to be, we will need to change some parts of its interface to make it like asynchronous and like a ability to sort of like halt the retry process and continue again. If you want to do this kind of thing today, you're probably just going to have to write a custom filter, and you can probably, there are certain hooks, for example, in the cluster manager to ask it to go off and fetch a new host to wait for something to happen, and then let you know as a filter in order to resume the traffic. So I don't think there's any plans to add this kind of thing like as an out-of-the-box in the API feature, but certainly as like an extension point, it should be possible to do it. And if it's not possible today, definitely open an issue on GitHub, and we can like follow through and try and work out the best way of extending the existing APIs towards that.
I think part of the feature for the on-demand XDS, which is planned in the plan, can somewhat work for your case as well. But like we don't have like any particular timeline for that feature when it will land.
Yeah, I'm very new to Kubernetes, and I want to ask your opinion on how would you explain service mesh, both the control plane and data plane, in plain English, maybe in 2 minutes. I understand like few things, but I want your perspective on this.
I actually wrote an entire blog post on this, but we can try. But I would encourage you to go look at my blog on this. I have a blog post called "Data Plane versus Control Plane." So yeah. I don't know. I mean, you want to? It's an API question. You can tune.
Sure. Yeah. So So from the perspective of Envoy, right, and even in a service mesh, we have the data plane where all the traffic is moving essentially, right, between the different services. And the control plane, which we sometimes confusingly call the control plane for the data plane, and sometimes the data plane API, which is actually even more confusing. But the control plane for this data plane is essentially delivering dynamic configuration and telling it, where to route various bits of traffic, how to do service discovery, what ports to listen on. All this kind of stuff is what these APIs are delivering. So the service mesh is, we've got a bunch of these envoys in a Kubernetes, each running individual Kubernetes pods, and you want to tie them together and provide cohesive traffic routing and management and observability over all of these. That's what the service mesh is, I think, in a nutshell. Yeah. Anyway.
So from a user perspective, I think AWS App Mesh is using Envoy, right? Envoy. Is that the easiest way to get started, to find a vendor that has a product that is already has Envoy installed, and then you get started, or?
I think it really depends on what you want to use Envoy for. And that's what I was saying before, is that we have people that are using it for API gateway, edge serving, service mesh. And there's vendors that are using Envoy for all of these things, lots of vendors. So I think the first decision point is what problem you're trying to solve. Is it service mesh or something else? And then you can focus on finding a vendor. Are you asking about service mesh? I'll let Lizan take this.
So yeah, I think it also depends on how your deployment works. Like if you're fully on AWS, probably you can try Envoy with the app mesh control plane first, and that could be a great start point for you. But it really depends on your actual use case.
So back to sort of the context of Kubernetes, I'm more familiar kind of with the service abstraction. Is the idea then with Envoy plugging that in and then it's sort of fitting within that mechanism? If you're running this in pods, then if you have does it play nice, obviously, with all of those constructs already, or does it introduce sort of its own out of context sort of approach?
Envoy really has nothing to do with Kubernetes. It's really completely separate. So we have people that use Envoy with console. We have people that use Envoy in Mesos. We have people that use Envoy in on-prem with their own orchestration systems. So people wrap Envoy in a variety of different ways. But from the Envoy project perspective, it's really orchestration agnostic.
Hey. Why don't we have working groups in this Envoy, another CNCF projects, or working groups? Working groups. Yeah. So are we going to plan to form these groups?
So, sorry, are you asking why does Envoy not have working groups? It's never really felt like we really need them. I mean, we have a bi-weekly community meeting. I think we're very happy to set up mailing lists and do project tracking however people want. I can't speak for all of them, but I'm not one who's for process sake. So I think we just want to find the right way of getting work done. Is there a context by which you're asking? Sure. I think the issue is that, again, we are a community-driven project. We're not a vendor-driven project. So we would need people that want to do work. So from a project perspective, we're very happy to start a working group, as in to make an email list or get you a Zoom meeting. But if there aren't people that are willing to do the work, I don't know what the working group would actually do. So we need people to come forward who want to do work. And we have the biweekly community meetings, so that's a great way of making yourself known. Did any of you want to add anything?
I would add that we do have one working group today, and that is the UDPA working group, which is not actually an Envoy working group, but it's a related working group. And I think there definitely is room in the areas of APIs, which is probably what that covers, but also performance and security to have working groups. Today, a lot of the security stuff is actually handled by the Envoy product security team, which is a volunteer effort, and there's a small group of us. And I think we're largely, we don't hear a lot from other folks who are interested in actually joining that effort. If there are, we're definitely interested in sort of vetting them and seeing if they would be interested in joining that organization, and that's effectively the Envoy security working group.
Hey, so I'm pretty interested in using Envoy either on its own or through a service mesh, but most of my company's traffic goes over NATS, which is TCP protocol. And I was wondering, like, what's the state of Envoy support for protocols like NATS or MySQL that aren't, necessarily HTTP? Because I've read conflicting things online. I'm not sure if it's just a matter I need to write the support myself or it's like impossible.
It's totally possible to write support whatever protocol you want. There was some work been done on a MySQL filter to understand a protocol, and I think it was primarily around stats with some ambitions on doing access control. Not sure what the state of it. I think it's partially done, partial support. And yeah, it really comes down to having somebody who's willing to put in the work to add support for it. You have full access to all the data being sent over TCP. You can do whatever you want with it. Yeah, just need somebody to do it.
Yeah, for NATS, I think solo.io has a NATS filter, but it hasn't been upstreamed. So I would talk to them about what the status of that is.
Hey, so we're currently rolling out Envoy to services progressively. I think we're in front of 2,000 different services, and as you said, all use different frameworks and languages. So we often, not that often, but we see problems that Envoy changing some header or not liking the header that is being sent by the upstream or the downstream or wherever. So usually what we do is inspect the traffic and see what's going on, how the requests look before going through Envoy, how does it look after going through Envoy. Usually I use TCP dump or something like that. I know that you have this tab filter, but I was wondering if, I think I raised a ticket in GitHub about that. Why don't you have support for this SSL keylog file instead? It's a way you can decrypt TLS traffic. Because with that, you can capture the request before it went through Envoy, and after it goes through Envoy, you can look at the differences on the headers or whatever it is. I was wondering why do you decide to maintain and create that filter instead of just supporting this NSS keylog file instead? And that's to capture the pre-shared key on the TLS traffic and be able to decrypt the.
Yeah, I mean, there's no reason we couldn't support that. I mean, I guess the idea is effectively what you want to do is something like TCP dump it, and then run Wireshark and be able to have the session key for TLS, so you can actually see what the traffic in plain text looks like. Today, the way we approach this, largely out of I think operational simplicity, was through L4 tap. This is before we added the L7 tap. And we essentially just added a transport socket wrapper, which will dump things out in Envoy's internal format. But we have a conversion tool between that and PCAP. So you can run this transport, if you configure this transport socket filter in its tap mode, you can basically get a PCAP file out in plain text as well. So that for us, for our various testing and security needs was sufficient. But I don't think we would object to someone adding that as a feature, so PRs are welcome.
Yeah, I mean, the only thing I would add is that the feature that you're talking about specifically, I think most people would consider it like a security disaster. So I personally, from an operational standpoint, I would not recommend doing that. If, as a contributor, like if you can find a clean way of contributing it, as Harvey was saying, I'm not sure that we would object to it, but I think it's doubtful that you're going to find one of us to add that. It's an environment variable. You're sucking out the key. Like I think most security people would run screaming from that feature. Sure, but the tap filter is it's a configured thing, right? Versus, like you say, an environment variable. It's there can be more control over it.
Yeah, environment variable is added to that, environment variable is the global processing. We would like rather to do have the configure per listener per cluster. To do that in the TLS context config, have the explicitly configured. That will be my preferred at that.
Since you guys are doing UDP, have you also looked at SCTP? Maybe you heard this question before.
I'm not an expert, but as far as I know, the work that I'm doing on UDP, it should work for SCTP. I don't know why it wouldn't. So once it lands, are you talking about specific protocol support, or would it work as a proxy? As far as I know, the work that will land should support it because it'll support session affinity. So it should work. So if you're asking on top of that for a filter that could do stats or something along those lines, I would open an issue.
So we are running Envoy as a sidecar to our services. We currently have two options to provide the config, either static or dynamic. Static is kind of not possible because of the dynamic environment, dynamic nature of our environment. But there is a huge risk that whenever the connection to the XDS broke, my containers won't start up, or they will fail. The whole communication will fail. Is there any plan, or is there any already existing way to provide a hybrid mode of configuration to Envoy, saying that use XDS as the first thing, but if the connection breaks, if something goes bad, use this hybrid mode, this config?
I can give you my personal opinion that doing that is a horrible idea. And here's why. Because you're not fixing the case where new instances won't work, right? I mean, you're looking for a Band-Aid over the fact that your control plane is not working. So putting on my SRE hat, I'd really recommend that you not do that, and you just need to make your control plane work, and you need to make your control plane scalable. And we've been asked this many times over the years, and that's been the pushback, and I really don't think we're ever going to support it.
Yeah, I'll just add a couple of things to that. So the first is, I mean, obviously, XDS as it works today, if you're already speaking to the XDS server, you're going to latch the last known good config. So that's already, kind of a win for that, but not for new, let's say, containers which are coming up. There's been a bunch of work which is just about to land around what we call aggregate clusters. So you can actually do things like fallback in your service discovery between different clusters, which is kind of neat. So for example, for folks who want to fall back from EDS to DNS, that's something that's supported today. I think in the context of UDPA, which is going to probably intercept the v4 APIs next year, there will be some more harmonization between what is possible statically and dynamically, and we'll be much more explicit about how we do overrides and things like that. Now, whether that's a good idea to use in operationally, as Matt points out, that might not be the greatest idea, but I think we want to make in UDPA things basically expressible both dynamically and statically, and providing a good story for overrides. It's actually part of our overall story of doing things like federation and so on, and that'll tie into that whole dynamic versus static within the proxy.
Thank you.
Not to keep sort of beating the same drum with Kubernetes, but I guess I'm just thinking about situations that you've seen where people are sort of using Envoy in conjunction with Kubernetes, whether it's like maybe ingress or, again, there seems for me to be some overlap between the service model, what's being done in there in terms of containers needing to reach out and find things. I'm curious how it has been sort of integrated in there, if at all. Maybe your answer is it's not really, but how it has been used in there.
Yeah, and like Matt said earlier, there's no like Envoy does not know anything about Kubernetes. Now, there's plenty of control plane implementations that like tie them together. Istio is one of them, which does kind of what you described earlier, where it it slurps up like the service directives and kind of generates like Envoy config, so that the transparent proxying that Istio forces makes it look like it's talking to the service, but it's actually being delegated to the sidecar, which is then doing layer 7 proxying with whatever extensions you added in TLS and whatnot. So I think that's like probably like the best example of how that's been done.
Yeah, I mean, there are tons of people, both on the ingress side and on the service-to-service space, who are binding the systems together. But that tends to be where they're taking CRDs and they're translating those to Envoy config, and how that is done is typically vendor specific.
I have a more like a philosophical question for you, Matt. When you started a project like Envoy, have you looked first if there was existing open source project you can modify, contribute? I think like there is a lot of reverse proxy, forward proxies, like even the worst, like maybe Squid or HTTPD. What are the motivation about starting a new project? And a follow-up question would be, aren't you afraid that at some point Envoy will be so developed that it will turn into something huge like those projects were 5 years ago? Or?
I think at the time the way forward would have been to fork Nginx, and that probably would have gone okay, right? Because I think at the time, this is almost 5 years ago, it was clear that Nginx at that time was not taking patches. It wasn't going to take a bunch of the stuff that we knew that we needed to do. So I could have forked it, right? I thought from a judgment perspective that C++ is way more productive than C. So I thought that we could move faster, build on existing libraries, and I thought that we could get something working relatively quickly. From empty files to production, I had something in production at Lyft in about 3 or 4 months. So I mean, it wasn't like a multi-year effort. Obviously, what existed then is a fraction of what we have today. So that's why. I mean, yes, there's lots of things that could have been done, but that was the judgment call that I made, and I was given, as they say, a large rope to hang myself with from a job perspective. But in terms of, like, will it get too big? I think there's a natural life cycle, right? It's like, is Envoy going to get replaced by something else eventually? Probably. What I think we're trying to do right now is we're trying to, as I was saying before, look at the Linux kernel for inspiration on how we can break things into the core of Envoy and to extensions. And I think that's actually the key of helping the project scale and have longevity, because if we can break it into component parts that can be compiled out, and there's very clean interfaces between the core and the extensions, it avoids it becoming this giant bloated thing. And I think that's what we're trying to do. Does anyone have any comments on that?
So you've probably covered this before, but I'm just curious about the motivation at Lyft. Like, what was it that you were doing that? I mean, not many of us work at places where we need to go write this kind of software from scratch. So just want to see if you could describe a little bit more about the problems you were facing that necessitated this.
You know, we, at the time that I joined Lyft, we had monolith. I think we had 30 services like written in Python, and the microservice rollout was basically paused because like no one knew how to debug anything. Networking around Python and service-oriented architectures is difficult, and so from previous experience, I had been at Twitter before Lyft and seen how people build large microservice architectures, and many companies before had done them using an in-process library. So at Twitter, it was done with Finagle, and Netflix has Hystrix. So it's a very common set of patterns that people do. But it was also clear that we couldn't write one library because we have to write it in PHP and in Python and a bunch of other stuff. So I knew what had to be done, and I knew that it had to be out of process because we're not going to write it 4 or 5 times. So then it's, do we use Nginx? Do we use HA Proxy? I think at the time someone proposed to me that we just do it in Python. No joke. And so, like all of these things are trade-offs. I think in hindsight, it's kind of incredible to me that Lyft actually let me go and do it, right? But that's history. But those are the problems that we were facing. Going once, going twice. All right. Thank you, everyone. Yep.